This video is on coordinate geometry, plane shapes. We're going to be looking at the properties of quadrilaterals. These are different than triangles. Quadrilaterals have 4 sides, and these are the types of quadrilaterals that we will be looking at. We have a parallelogram, a rectangle, a rhombus, a square, a kite, a trapezoid, and an isosceles trapezoid. There's also called a right trapezoid, which is a trapezoid just with a right angle. So the properties that we have for a trapezoid will still be the same. It's just will also include right angles. Each parallelogram or each quadrilateral, each quadrilateral has its own equation for the area as well. So I'm going to start with that. The type of quadrilateral is a parallelogram. This area would be base times height. Very similar to a rectangle. Actually, the rectangle has the area of base times height, or length times width if you remember back from elementary. So we can also say that area is equal to length times width. Either one is the same, it's fine, they mean the same thing. A rhombus is a brand new shape. Now, a rhombus people think of as a diamond, and it's very important to understand that a rhombus is not necessarily a kite. A rhombus has all 4 sides congruent, and we'll get into the properties of that. But a rhombus has a very specific formula. The area of a rhombus is 1/2, which is different because it's not just base times height, is 1/2 times the first diagonal, so diagonal 1 times diagonal 2. We actually have to find the lengths of the diagonals, not the sides, to be able to find the area of this. So I'm going to write a little note to remind us that D in this case is the diagonal. A square has actually, you could utilize 3 different formulas for it. So the first one is area equals base times height, just like a rectangle, or area is equal to length times width, just like a rectangle, or because it's a square, and squares, hopefully we know, that have all the sides are the same, that means that the length and the width have to be the same. That means that area would be the side times the side, which is side squared. So we could say area is equal to S squared, which is the side length squared because all the sides are the same. The next quadrilateral is a kite. Now, a kite and a rhombus actually are very similar in nature, and therefore they have the same equation for the area. So for a kite, the area is equal to 1/2 times diagonal 1 times diagonal 2. So the first diagonal times the second diagonal. Trapezoids are new shapes. Trapezoid is actually a triangle with the top cut off of it. So we're actually going to utilize the area of a triangle to help us. The area of a triangle is 1/2 base times height. So we're going to utilize the area is equal to 1/2. And a triangle has 1 base, and then it goes to a point. But a trapezoid has 2 bases because we've cut the top part of the triangle off. So we've created a top base. So it's not just base times height. We have now created 2 different bases. So our equation will be 1/2 times our height, because there's still only 1 height, times, it's still going to be base, but there are 2 bases. So we have base 1 plus base 2, because we have to know how long all of the bases are. So we have 1/2 times height, because there's still only 1 height, times your base 1 plus base 2. So we would just add our 2 bases together to make our singular base for the original triangle. And an isosceles trapezoid is still a trapezoid, so we would actually have the same formula for the area. So area is equal to 1/2 height times base sub 1 plus base sub 2. And when we look at the pictures and the properties, this would make a little bit more sense of where bases and diagonals come from. So going back to the parallelogram, we're going to talk about the properties. Properties of a parallelogram actually are that the opposite sides because there are four sides, the top and the bottom and then the left and the right basically are congruent. So that means the top and the bottom are congruent and the left and the right are congruent. And it's called a parallelogram for a reason. The opposite sides are parallel. Now we don't have a coordinate plane, so therefore we're going to draw a picture of this. A parallelogram kind of looks like a rectangle that's been tilted. This is your general shape of a parallelogram. Now when it says opposite sides, that means the top and the bottom and the left and the right. So congruent and parallel have markings. So for congruent, we would use tick marks. So I have the left has one tick mark and the right would have one tick mark. But then I also have to have top and the bottom. So the top needs to have two tick marks and the bottom needs to have two tick marks. Now I did leave a little bit of space because I need to mark the parallel as well, which is why I didn't just put them in the middle. So that's the congruent piece. Now the sides that are parallel go back to the arrows inside of the lines themselves. So if I want to say the top and the bottom are parallel to each other, I would put an arrow inside of it. And I'm going to use one arrow on the top, therefore I need to use one arrow on the bottom. Well, the left and the right are also parallel, so I'm going to use two arrows on the left and two arrows on the right. Again, the reason why we didn't use one arrow on the left and on the top is because these are not parallel. They actually intersect. So the amount of markings tells us which ones match together. So the base here would be the bottom piece, basically, but the height actually is the piece that goes straight from the base straight up. So you would actually have to calculate or count on a coordinate plane the height of this, and it would go straight up and not diagonal. A rectangle has the properties of this, has opposite sides. So again, the top and bottom and the left and right. Opposite sides are congruent, just like in a parallelogram, and parallel, just like in a parallelogram. And if you think about it, a parallelogram is just a rectangle tilted. So let's untilt it. When we untilt it, a rectangle will actually, instead of being diagonal here, it'll go straight up, which means you have perpendicular. So we would say and so it has the same properties of a parallelogram, but it has one more. And connecting sides, which are also adjacent sides. So connecting or adjacent, so that would be the top and the right, the top and the left. Connecting sides are perpendicular, which is that upside down T shape. So if we draw out a rectangle, our general shape of a rectangle, we need to mark them. So again, opposite sides are congruent. So again, that means that the top and the bottom are congruent. So I'm still going to use one tick mark and one tick mark on the top and bottom. On the left and the right are congruent, so I'm going to put two tick marks on the left and two tick marks on the right. Opposite sides are parallel, so the top and bottom are parallel. I'm going to put two arrows on the top and bottom. And then the left and the right are parallel, so I'm going to put one arrow on the left and one arrow on the right. And connecting sides are perpendicular. The symbol or the marking for perpendicular are the right angle markings, which are the squares in the corners. This is the difference between a parallelogram and a rectangle. They have the same properties, except a rectangle has very specific types of angles. A parallelogram has one obtuse angle here and then one acute angle. So those are different. A rectangle have the same angles. See, this is 90 and so is this one. A rhombus is our next one. A rhombus is where all sides are congruent, not just two, not just opposite, but all four sides. And opposite sides are parallel. So again, that goes back to top and bottom, left and right. All sides will be congruent, but the top and bottom are parallel, and then the left and right are parallel because they will still connect and make the four-sided shape. Now, a rhombus is kind of like a diamond. That's what most people think of. I still want to have a horizontal piece here. And it's actually going to still look like a parallelogram. It's going to be tilted. And this still looks more like a diamond. So the difference between a parallelogram and a rhombus is that a parallelogram, only the left and right were congruent, and then the top and bottom were congruent to each other. The rhombus has all four sides are congruent. So I would actually put the same amount of tick marks on all four sides. I'm going to put one on the top, one on the bottom. I'll also put only one on the left and one on the right. All four of these are congruent. It is tilted. The difference between a rhombus and a square is that one particular property, just like a parallelogram and a rectangle. A parallelogram is just a rectangle tilted. A rhombus is a square tilted. So the rhombus has the four sides congruent, but not the angles. We also still need to show that the opposite sides are parallel. So I'm going to put arrows. So I'm going to put two arrows on the bottom and top to show that those are parallel. And I'll put one arrow on the right and on the left to show that those are parallel. Again, the left and the top are not parallel to each other. So when I said the diagonal here, this would be your diagonal. So from the bottom left corner to the top right corner, we would need to find the length of that diagonal. We would also need to find the length from the top left to the bottom right. Now these distances or these lines are not the same length. So you actually have to find the length between both of those. Or you have to find the length of both of those diagonals. They are not the same length. Next up is a square. A square has all sides are congruent. And obviously the opposite sides are parallel. But so it's going to have the same properties of a rhombus, but one additional property. So we know the opposite sides are parallel, but the big difference is this next property. So, and the connecting sides are perpendicular. So we only have to have all sides congruent and the perpendicular part to show that it's a square, because if they are already congruent and then perpendicular, then the top and bottom automatically have to be parallel in order for them to have the same length and then connect at right angles. So we don't actually have to prove that the top and bottom are parallel, because they would automatically be if all sides are congruent and the connecting sides are perpendicular. So drawing this shape out, our general shape of a square, we would need to put the markings for all sides congruent. So again, I would use one tick mark on the top, the bottom, and the left and the right, just like in a rhombus. But again, the big difference between a rhombus and a square is that a square has the right angles. So that perpendicular gives us the right angles, which puts those squares in each corner. So these are all 90 degrees each, which is the big difference between a rhombus and a square. So a parallelogram is a rectangle tilted, and a rhombus is a square tilted. So because these, again, the sides are all the same, length times width, so the length or the base times the height, these would have to be the same measurement. So this was a side, this is also a side. Side times side is side squared. The next shape we're going to look at is a kite. A kite has the different properties. This is the one that is a little more complicated to comprehend. A kite has two sets of adjacent sides or connecting sides are congruent. These are not the opposite sides. And a kite has nothing that is parallel. So that is the biggest difference between a kite and everything we've seen so far. A kite has no parallel. So the shape of a kite is like an actual kite that you might have flown on the beach. This is the shape of the kite. And you can see that these sides are not the same, but they are also not parallel. So we're not going to be marking any parallel. Where it says two sets of adjacent sides, that's because it's not the opposite. So it's not the left and then for the top left and the bottom right. Those are not going to be congruent. It's actually going to be the two that are basically at the top here. So the top and the top are congruent to each other. And then the two sides on the bottom are congruent. So it's not all of them that connect. These two sets of sides connect or are adjacent at this point at the tip. And then the other two connect at the point at the bottom. So it is important to notice that yes, the left sides, there's a top left and a bottom left, they also connect, but it's not all sets of adjacent sides. It's specifically just two sets. So the top set and the bottom set, not the left set. So we have one tick mark on the top left and two tick marks on the bottom left. Those are not congruent to each other. So when it says the area is 1/2 diagonal 1 times diagonal 2, that is still the diagonal, so a corner to another corner, diagonal across. So this one would be across, which is a small diagonal. And then your other diagonal would be from the top basically to the bottom. And we can clearly see that these lengths are different. We have a smaller one, and then we have a much longer one. So we would have to find the lengths of those. So a kite has no parallel, so we only have to find the distances, and including the distances of diagonals, so that way we can find the area. The next shapes are trapezoids. So a trapezoid has only one set of opposite sides that are parallel. So again, this is a triangle basically with the top part of the triangle cut off. So if I were to draw this, I would have the bottom piece of a triangle, and then I would start drawing my triangle, but I would cut the top part of it off. And I would have two bases. So it's basically, this would be the triangle, and we just cut that piece off. And it formed a second base. So this one has only one set of opposite sides are parallel, not all opposite sides. So we have to look to see which set would be the parallel. And on the coordinate plane, you would do that with the slope. So on this one, generally it's going to be the two, that's what we call the two bases. So the bottom base is going to be parallel to the top base. So when we talked about the area being 1/2 height times base 1 plus base 2, these two sides that are parallel would be your bases, and we would add this length plus the bottom length to find our full base. That's what this value would be. The height would still be between the top and the bottom. So we would have to figure out the height going straight up to make it perpendicular with one of the bases. So there's no congruency on here for a general trapezoid. It's just one set of opposite sides are parallel. So only one set. So only the top and bottom basically. If the picture was turned, it could be the sides, but it is based off of the slope. Now an isosceles trapezoid is still a trapezoid, but it will be isosceles. And isosceles means two sides are congruent. So we're going to have, I'll go with brown, one set of opposite sides parallel, same as a trapezoid. But then the other set of opposite sides will be, as isosceles, those will be congruent. So I'm going to draw my trapezoid out again. Basically a triangle with the top cut off. I'm going to put my opposite sides that are parallel the same way I had it earlier. So the top and the bottom are going to be my two bases. Those are going to be the parallel. But it says the other set of opposite sides. So I can't use the top and bottom again. I'm going to have to use the left and the right. The left and the right side will be the congruent piece. So I'll put tick marks on those. The other trapezoid that is not on here is a right trapezoid. It would look like a trapezoid, but you'd have a right angle. So I'm just going to draw this just so you can see it. It would be a right angle. So I would have to have the base and a vertical piece. Now to be a trapezoid, it has to have a parallel. So those two pieces have to be parallel. The bottom and the top have to be parallel. But then I still have to connect to be a trapezoid. So again, if it was all the sides were the same, it'd be a square. So I can't have that. I have to have a trapezoid where only two sides, so the top and the bottom, are parallel. A right trapezoid would have a right angle, and it would in fact have two right angles. It'd have the top base and the bottom base would have a right angle with one of the sides. Not both, but just one of the sides. So that's what a right trapezoid would look like.